بسم الله الرحمن الرحيم. أعزائي طلبة وطالبات شهادة الثانوية العامة قسم رياضات لغات، أهلا بكم. اليوم سنتناول إلى درس بعنوان مراجعة على اليونت 1 ويونت 2. طبعا احنا عارفين يونت 1 بتتكلم على الفريكشن ويونت 2 بتتكلم على المومنت. Welcome my dear student in our math program for secondary 3. Today we are taking revision about unit 1, unit 2. What is about unit 1? Friction. What about unit 2? Moment of the forces about 2 dimensions and 3 dimensions. My dear student, look at the first example. Look at my dear student. Two bodies, their weight are 3W, 4W. Connected by light string coincides with the line of the greatest slope of an inclined rough plane. My dear student, note that we have two bodies. The first, its weight 3W, second 4W. Connected by light string coincide with the line of greatest slope of an inclined rough plane. The coefficient of static frictions between them and the plane are 1/6 and 1/8. Coefficient, my dear student, of static friction mu s of the first equals 1/6, second equals 1/8 respectively. What you mean? 1/6 for 3W, 1/8 for W. If theta, my dear student, is the measure of angle between the plane and horizontal plane, is increased gradually. My dear student, theta is the measure of angle between the plane and horizontal plane, is increased gradually. Which of two bodies should be placed below the other to make the two bodies move together? Keep the string to state the reason. Then prove that, my dear student, tan theta equals 1/2 when the two bodies were about to slide. Look at the solution. My dear student, we have a rough plane inclined to horizontal by angle. The first, we have two bodies. The first body 3W, the second body 4W. Look at, my dear student, we have two bodies. The first body 3W, we resolve 3W about two perpendicular, 3W cosine theta and 3W sine theta. Look at this remark, is very important. The body whose coefficient of friction smaller than is placed below the other. Remark, my dear student, the body with coefficient of friction is smaller, 1/6 or 1/8, or 1/8 is smaller, is placed below the other. For 4W body, we have equation about the body of its weight 4W. The body is about to move down. What you deduce? T equals T plus 1/8 reaction of the body R2 equals 4W sine theta. R2, the second equation, 4W cosine. By substitution about R2 equal 4W cosine, therefore we deduce T plus 1/8 multiply 4W cosine equal 4 sine theta, therefore T equal 4W sine theta minus 1/8 times 4W cosine theta, therefore T equals 4W sine theta minus half W cosine theta. This equation number 1. My dear student, we have T and theta is unknown. the tension for the body with its weight 4W, tension equals 4W sine theta minus half W cosine theta from this equation from 4W weight. Now we are translate to 3W weight. The body about to move down. Therefore, from the opposite graph, we deduce that 1 over 6 R equal T plus 3W sine theta, the first equation for this body. Second equation, R1 3W cosine theta. By substitution, about R1 equals 3W cosine theta, we find the relation between tension and theta. Therefore, T equals half W cosine theta minus 3W sine theta, this equation 2. We know that the first equation start from T left hand side, and second equation start in left hand side also tension T. From 1 and 2, my dear student, we form the equation 4W sine theta minus half W cosine theta equal half W cosine theta minus 3W sine theta. Therefore, 7W sine theta equal W cosine theta. Therefore, sine over cosine or equal 10, 1 over 7. Therefore, 10 theta equals 1 over 7. My dear student, look at the important example. This example about moment. Find algebraic measure of the moment of the force whose magnitude F equal 15 Newton about the point A. Solution. My dear student, look at in the opposite figure. My dear student, we have force represent vector NBC vector. Force equal 15. Angle equals 150. Angle BCA. Moment is L times F. What is the L, my dear student? Excellent student. L is perpendicular AD equal AC sine 30. We know that the side which opposite angle 30 equal half length of the hypotenuse. And by using calorie of Pythagoras theorem, L equal half C. Therefore, my dear student, L equals, we have CBA isosceles triangle, each one is 4. Therefore, AD perpendicular to BC, L length of the arm equals AD. AC sine theta equals L. AC sine angle ACD equal 4 times half equals 2 centimeter, or L equal half length of hypotenuse equals 2. What is the moment about A? F times L. What is the F? Magnitude of the force. What is the L? Length of perpendicular. Therefore, MA 15 times 2 equals 3 Newton dot centimeter. Remember, my dear student, units of moment about the force equal units of the force times unit of the distance or the length. 15 is the magnitude of the force with Newton. 2 is length of the arm L in centimeter. Then moment about A equals F times L. 15 times 2 equals 30 Newton centimeter. My dear student, we can solve this problem by another solution. Moment about A, norm F, norm AC, sine theta. Therefore, 15, this norm F. AC, its norm 4. Sine angle between them 150 by using calculators. Then moment about A equals 30 Newton centimeter. Moment of the force of F 15 Newton about the point A. We draw AD perpendicular to BC to find the value of L. F square 5 square minus 4 square equal 3 centimeter to find the value of L. Moment about A. This moment clockwise with negative sign, negative F times L, negative 15 times 3 equal negative 45 Newton centimeter. My dear student, look at the force which represent F. What is the norm of AD is L equal 3 centimeter by using Pythagoras theorem. L equals 5 minus 5 square minus 4 square under square root equal 3 to find the moment about A. Find the value of F times length of AD. We know that the force 15 when act at a point A with clockwise. What do you mean clockwise? Its direction is negative. Negative 15 times 3 equals what? Negative 45 Newton centimeter. This is clockwise direction is negative direction. Now, my dear student, we translate to another example. ABCD is square of side lengths 8 centimeter. Forces of magnitudes 2, 5, F7 and 6 root 2, 8 root 2 gram weight along AB direction, CB direction, AD direction, DB direction respectively. If the line of the action of the resultant of these forces is parallel to AC, find the value of the force F. Solution. Look at, my dear student, we have square ABCD. Look at the forces. The forces, two direction AB, its force act in AB 2, CB 5, CDF and AD 8 root 2, square its side length 8 centimeter. My dear student, ABCD square, therefore two diagonals AC equals BD, each one 8 root 2. Why? Because if we have square its length 8 centimeter, its diagonal its length must be 8 root 2 by using Pythagoras theorem. Therefore, my dear student, AM half AC equals MC equals what? 4 root 2 centimeter. The line of action of resultant is parallel to AC. What do you mean? Moment about A equal moment about C. My dear student, if the direction of the moment parallel to AC means moment about A equals moment about C. In this case, we find the moment about A and find the moment about C and make equation left hand side equal right hand side. Moment A by the method equals F times L. The first F, fourth F, 2 times 0, second 5 times 8 minus 5 times 8 plus 7 times 0 plus 6 root 2 times 0 plus 8 root 2 times 4 root 2. Answer is 40 minus 8F. This is moment about A. Moment about A equals 40 plus 64 equals 104 minus 8F. This moment about A. My dear student, note that the second we find moment about C. Moment about C by the same method, negative 2 times 8 plus 5 times 0, negative F times 0 plus 7 times 8 plus 6 root 2 times 0 minus 8 root 2 times 4 root 2 equals negative 24. My dear student, we know that moment about A equals moment about C. Why? Because the line of action of the force parallel to AC, this rule. If the action of the line of the force parallel to AC means MA or moment about A equal moment about C. Therefore, in left hand side 104 minus 8F equals negative 24. Find the value of F equals 16 gram weight. My dear student, in this case, if the force is unknown, to find it, we make equation moment about A equals moment about C. Why? Because action of the line of the force parallel to AC. My dear student, look at, my dear student, to another example. The two forces F1, 2I vector minus 6J vector and F2 vector equals I vector minus 3J vector act at point O, origin point 0, 0. Let A equals 1, 2, its coordinates, and B point for negative 1, its coordinate. Prove that, my dear student. The sum of moments about A is equal to sum of moment about B. Explain this result. My dear student, look at the solution. F equals or resultant of the two forces F1 plus F2. We add component of I and component of J, 3I minus 3J. R vector equal AO vector equals O minus A is point A, negative 1, negative 2. Moment about A, R vector cross F vector by using vector multiplication. Negative 1, negative 2 is R vector cross 3, negative 3. This is component of the force F. Therefore, negative 1 times negative 3, 3 minus negative 2 times 3, positive 6. Answer is 9K vector. K is unit vector of moment about A. Moment about B, we find R2. R2 means position of the vector at point B. R2 BO O minus B or equals component of point B negative 4, 1. Moment about B equals R2 cross F. By the same method, we find moment about B negative 4, 1, its coordinate of R2 cross moment about F 3, negative 3 equals negative 4 times negative 3 equals 12 minus 1 times 3, 3. 12 minus 3 equals 9K. Then we deduce that moment about A equals moment about B. Why? Because each one is 9k vector. Moment about A equal moment about B. What you mean? The line of the action of the force parallel to AB. My dear student, if moment A equals negative moment B, what you deduce? Excellent student. The action of the force F bisect AB. But in this case, if we have moment about A equal moment about B, we deduce that the line of the action of the force parallel to AB. My dear student, look at another example. In the figure, AB direction represent a crane for lifting the goods. If the tension in the string is equal to 140 Newton and the weight of a box is 125 Newton. My dear student, in the opposite figure represent a crane for lifting the goods. We have goods, we lift it by crane. If the tension in the string is equals to 140 Newton and its weight of the box 125 Newton. Find the sum of moments of the two forces about B. Look at the solution. My dear student, look at AB equals 12 centimeter. Look, my dear student, AB 12 centimeter. This angle theta inclined by horizontal, crane by horizontal theta. We resolve 140 by two perpendicular axes, 140 cosine in horizontal, 140 sine in vertical. My dear student, by resolve the tension force, moment about B equals 140 cosine theta times length or arm 12 minus 140 sine theta times 4, negative 125 times 4. To find the value of moment B by substitution about cosine theta and sine theta, moment about B equals 60 Newton meter. Look at another example. The force F 4I plus 3J act at a point A, negative 3, 2. Let B, my dear student, negative 1, negative 2, and C, negative 5 and 6. Using moments, prove that the line of the action of the force bisect CB. My dear student, look at the solution. R1 position vector of the point B equals BA equals what? A minus B. Negative 3, 2 minus negative 1, negative 2. Answer is negative 2I vector plus 4J vector. R1, R2, CA, negative 1, negative 3, 2 minus negative 5, 6 equals 2I vector minus 4J vector. This is CA vector. Moment about B are vector cross F vector, negative 2I vector plus 4J vector cross 4I plus 3J vector. We multiply by using I use I, negative 22K vector. Moment about C by the same method, R cross F negative equals 2I negative 4J cross 4I B equals negative moment about C. What you deduce? Action of the line of the moment bisect BC. This is condition of when prove that the line of the action of the force bisect BC. Must we prove moment about B equal negative moment about C. And we know that moment about B negative 22K, moment about C 22K. Therefore, my dear student, moment about B equal negative moment about C. The line of action of the F bisects CB. My dear student, by the end of the lesson, I am very happy to spend such time with you. Thank you. Goodbye.